All right, let's get right into it. If you've been anywhere online lately, you've probably seen these really dramatic headlines swirling around about the very center of our planet. They're asking some huge questions, and today we're going to get to the bottom of them.
And yeah, that exact phrase has been popping up all over the news, and for a really good reason. Scientists are tracking this massive change thousands of miles below the surface, a change that's kind of challenging everything we thought we knew about how the Earth works. It sounds like the beginning of a sci-fi movie, but this is happening in the real world.
And this is the question that's at the heart of all of it. It's confusing, and let's be honest, it's a kind of scary idea, right? A giant metal ball at the center of the Earth just reversing course? Well, the answer is a little more complicated and honestly a lot more fascinating than just a simple yes or no.
So, to really wrap our heads around what's going on, we first need to take a little journey to the center of the Earth. We have to understand the main character in this story, the inner core itself.
Okay, think of it like this. Our planet has another, smaller planet deep inside it. This inner core is a solid ball of metal, incredibly hot, but it's under so much pressure that it's literally squeezed into a solid. And because it's just floating there in a sea of molten metal, it doesn't have to spin at the same speed as the rest of us up here on the surface.
And this difference is everything. You've got the solid inner core, that's our spinning metal ball, and around it you have the liquid outer core. This liquid layer is what lets the inner core do its own thing, spin freely. Oh, and it's also the engine that creates Earth's protective magnetic field. This whole setup is the key to understanding everything else.
Okay, so we've got the picture of the core. Now let's get to the big discovery. Using decades of data from seismic waves, that's basically energy from earthquakes that travels through the planet, scientists have been able to track the core's movement, and what they found was pretty remarkable.
This is the big headline from the recent studies, especially one from USC. It's not that the core just slammed on the brakes. No. Instead, its speed has changed compared to the spin of the surface, the part of the Earth we're all living on. So, what does that change actually look like over time?
This timeline really breaks it down. For decades, the inner core was in what's called superrotation, which just means it was spinning a little bit faster than the rest of the planet. But then, right around 2010, that started to change. It slowed down until its speed basically matched the surface. And now, it's actually entered subrotation, meaning it's spinning slightly slower than we are.
And believe me, this was not an easy discovery. As the researcher John Vidali says here, the first hints were just baffling. But as more and more data came in, from all these different earthquakes and even old nuclear tests, the evidence became undeniable. The pattern was real, and it forced a major rethink of how the deep Earth works.
Okay, so let's just make this super clear. The core is not spinning backwards in some cosmic U-turn. It's still spinning in the same direction as the rest of the Earth. But relative to us on the surface, its behavior has totally flipped. To really get this, let's use a simple analogy. Imagine you're driving on a highway. Okay, you're going a steady 60 miles per hour. That's us, on the Earth's surface. Now, in the lane next to you, there's another car. That's the inner core, and it's going 61. So it's slowly pulling ahead of you. That's what things were like before 2010. But then, that other car slows down to 59 miles per hour. Now, it's still moving forward, right? But from your point of view, inside your car, it now looks like it's going backwards. That's exactly what's happening with the Earth's core. Now, this all sounds pretty distant and abstract, but you're probably wondering, okay, so what? Does this actually affect me? And the answer is, yeah, it does, but in really subtle ways. Let's take a look.
The gravitational pull between the inner core and the layers above it could be affecting the length of our day, but listen, we are talking about fractions of a millisecond. It's not something you would ever notice. What might be more significant over long periods of time is how this little dance could influence our planet's magnetic field. But really, the biggest thing is that this discovery gives us this profound new window into the deep, mysterious forces that shape our entire world.
So before anyone starts to panic, the most important thing to understand is that scientists think this is all part of a natural cycle, an oscillation that might happen every few decades. This is not a sign of some catastrophe. It's a sign that our planet is a much more dynamic, living system than we ever imagined.
Which really just leaves us with this final thought. We've explored the deepest parts of the ocean and we've looked out to the farthest stars, but the world right under our feet is still one of the greatest frontiers of discovery. This change in our planet's heartbeat is a huge reminder that there are fundamental secrets about our own home that we are just beginning to uncover.